Okay, guys, welcome to ICE Education. My name is ICE Education. Zandile Mabuza, yeah, she's here. Mabuza. Okay, Mr. Bubakar, let's go. They said an hollow shaft which has a material is ductile. Okay, forgive my English. With diameter 50 and 80 respectively. Is an hollow shaft. An hollow means this is a shaft. When I talk about hollow, it means a shaft with a wall. That's what it means. So it means you have two diameters of the big one and the inside here. So if you read, you are given two diameters. You have 50 and 80. Just by the size, you can see which one is the outside and which one is the inside. Yes, you can see that. Now, they say is subjected to an axial compressive force. Remember, when we talk about this here, this is what we call a direct force. A direct force is a force being applied straight to the shaft. It is compressive or tensile. Compressive means it's going to the shaft. It has a negative sign. Tensile, it means it's going away from the shaft. It is positive. So this simply means that when you solve for your stress in this case will be negative because it is a compressive. That's what's happening. And you have a torque of 2.2 kilonewton and a bending moment of 1.7 kilonewton. Yet here they said calculate the factor of safety according to both yield criterion. Use the strength of this one. If you guys remember, when we talk about both yield criteria, we are referring to Tesla and Tresca. I don't know if you remember, but yeah, we did it on the test one. But when we solve it, you will see we're gonna remember what's happening here. Okay, first thing to do to solve this problem easily is to pick up each force. Let me not say force. Each element in this equation and what effect it does on the system. Once you can get it, you can solve the system. Like for instance, I have both diameter. I can call them big D to be 80. Is it millimeter or meter? I have no idea, but they were supposed to specify the unit here. During the test, did the lecturer give the unit
It's
here?
millimeters.
Oh, I'm not sure.
It,
It is supposed to give the unit. Okay, I believe it's millimeter. I believe in you, Mabuza. Now, we have a compressive force F here, which is 50 kilonewton. We recall everything. We have a torque, which is 2.2 kilonewton meter. And then we have a bending moment, M, which is 1.7 kilonewton meter. And we have the yield strength. How do we represent yield strength again? I forgot how to write it. How do we write yield strength again, guys? It's something like a S. Scroll. Anyway, I don't remember it, but it's something like a YST, if I remember well, something like this. But anyway, we'll see as we write it, as we start solving. This thing looks a bit thicker. Let me reduce it a bit here. It's 4 fine here. 4 is fine. Okay, now we have to study the effect of each force and what stress it is causing. The force that is axial, going straight, it creates a direct stress. And as we know, direct stress is equal to force over area. So what is the force? The force here would be minus 50,000. 50 times 10 to the 3. Why am I putting minus? I am putting minus because it is a compressive force. That's the only reason. If it is tensile, it is a positive. Now, you can see it's kilonewton. If I want it in Newton, we do multiply by 1,000. I'm 1,000. I'm 2,000. Guys, no one will fail. No one will fail this guy exam. Whatever we are doing here is what will give you on the test. It's not complicated, Rosa. It gives you, and you guys saw his test. He gives you what you studied. So if you can redo everything, check everything, you should be fine. Yes, Mr. Koso, what is next? What is the area? Because we have an hollow shaft, area will be pi over 4 big diameter minus small diameter. Okay, big diameter square minus, ooh, this is where, am I missing something? For an hollow, it is big diameter square. Is it d minus d square or d square minus d square? Mr. Koso, what is it, my leader?
Yes, you are correct, Mr. Ice. It's like that.
It is like this
Like
one.
it's the one. Yeah, d squared minus d squared. Yeah, that one.
Okay, thank you, my leader.
Yeah.
Yeah, it's revision is normal for us to forget, so we are refreshing our minds. So minus 50. So please take your calculator so you can move fast. Now you have pi over 4. If you're asking me where is the pi over 4 coming from, diameter 0, 0, is it 0,008 4 is millimeter. 0, hey, scalas baning. I think it is 0,08. But you know you can convert also on your side there. And then we have the answer. Okay, the area here, remember we refer to, this one is an hollow shaft. We look at this part here as a circle. Area of the circle is pi r square. Or as we can see, we know that radius is equal to diameter divided by 2. So otherwise area is pi diameter divided by 2 square, which simply give you pi, because 2 square is 4, pi d square. This is how we get the pi over 4. Now in this case we have big G minus small d because it is an hollow shaft. An hollow shaft has an inside diameter and outside diameter. So that is where the formula comes from. In case you want to, you have a question about it, that's it. So now, if you calculate this, what do we have as answer? Guys, let's move fast, please. Let's move fast. Can you give me the answer here? I don't have the calculator. Hello? Hey, Mafetsu, let's if we, guys, we are back again. Take your calculator, give me the answer, and we move to something else.
Mr. Alex, my brother.
Yes, what's the answer, my brother?
Let me double check here.
Please
Uh,
also check my conversion of this millimeter. I'm not so sure about it, so you can check there. You can tap 80 divided by 1000. It should give you the right answer.
It's minus 16.32 MPa.
Minus 1, 3,
16.
1, 6.
0.32 MPa.
0.32 MPa. Okay, now we move. Next, we look at the effect of the other force. We have a torque. Okay, we'll come to the torque after. Let's look at the bending moment. What does the bending moment? It creates also a direct stress, guys. It also creates a direct stress, guys. Remember,
Hi, I'm getting a different answer.
If you are using what
Yes. You got a different answer because I made a mistake to the power 4 instead of power 2.
Oh, what's happening with me
here? Isn't it supposed to be to the power 4?
No, it's 2.
So,
The area is this one. Why did I get 4, Mr. Koso? I think there was somewhere we're writing a formula with 4. It's chapter 16, eh?
No, it's the same chapter.
Mr. Isaac, to the power 4 is when you want to find the inertia, isn't it? Pi over 64 d over 4
D4.
minus
Yeah, that
when
one.
you want to find.
Okay, Mr. Koso, we also have a bending moment. Okay. What is the moment does? The moment also create a direct stress. This chapter is more or less linked to chapter 16. Remember, when we were studying stress distribution, we were studying like one force can create bending, it can also create direct stress. In this case, what's happening here? You have an hollow shaft. There's a compressive force to it, which is Mr. Koso, if you press, do you see your hands, right? If you hold it still, Mr. Bubakar, right? If you press your hand, what's the tendency? Oof, how can I say it in the good English? If this is your arm, this is your hand, and I come and press this arm, let's say I push your arm, what's gonna happen? You find your hands with the tendency of moving back, like pressing back or going down. I don't know if you see it. How can I explain it practically? But I want you to picture it. Like, just try to feel what I'm saying. You have your hand and someone come and push your hand. You will have a tendency of, like, they are pressing your hand back, which is pulling down, something like this. That's one of the reasons why the compressive force is negative. It's basically pushing more or less this thing in, but in the meanwhile, it is also like taking it down, like trying to press it. It will not take it down much because these forces apply directly, but if you look at it physically, it will have that tendency. That's one of the reasons when you pull an object, when you pull with your hand becomes straight. I don't know how to say it properly, but if I hold your hand, I pull it, it will stand still. Oh, forget the English. It will stand still straight. That's one of the reasons why the direct force is positive. So now the bending moment here. The bending moment created by this rho is equal to my over I. Oh, this is important. Yeah, this is really, really important. What is m? M is the bending moment. It is 1.7 times 10 to 3. Now, what is y? Y is usually here. Y is more or less like your radius. But here is the thing. In this case, even if it is an halo, we consider the y of the bigger circle. So in this case, y of the bigger circle is 40. So you will have 0,04. But when it comes to the moment of inertia, which is pi over 64, unless I'm making a mistake, here it's supposed to be g4 minus g4. This is where I have mistaken it. So now you'll ask me a question, why is it like on y we are not doing r small minus r big? Because when we're talking about the y here, we are studying the stress from the center point to the upper point.
Mr. Ice.
Yes,
Mr. Ice.
yes, Manida.
Are you not making a mistake there for the y? Aren't you supposed to take 0,05? Not even the radius, just 0,05 as it is.
No, the y.
I'm not making a mistake.
Are you sure, Mr. Ice?
Yeah, I'm sure. Mr. Abubakar, what were you about to say?
No, I was saying that the y is correct.
I'm not making a mistake, Mr. Koso. I don't think I am.
Ice.
Yes.
Yes, can you please care to explain the concept of bending stress?
Oh, the concept of bending stress.
Mm.
Okay, how can I explain this? Do you see when you have a bending moment? This is more or less like chapter 16. If you have a bending moment, a force, let's say you have a force that is creating a bending 1.7. Let's say that force it is like this. 1.7. Bending means it is pulling it down. I don't know. If your hand is like this and I push it down, you will bend. You will bend to a certain angle. You will change a position. This is bending. But now, there is something that is happening is, do you agree that, let me try to put it practically. If this is attached to a wall before bending, this is before bending, and now I have bent it. I have bent it. Do you agree that on this side, because of my bend, there is a displacement created here? I can call it X. Do you see what's happening? Something like a tensile force, something like that. It's just practically. That's one of the reasons. If someone bends your hand, you will also have the tendency that they are pulling it somewhere here on your shoulder. It's a practical thing. Now, the concept is this one. This force is a bending moment. Meanwhile, it is also creating what we call a direct stress. Why? Because when you bend an object at a certain point along here, that same object will also create a direct stress. Yeah, who's calling me? Oh, 1 minute. Oui, alors, doit. Yeah, ça va. Je peux te rappeler dans 40 minutes. Ok. Sharp. Oh. Okay, guys, yeah, I'm back. So here is the concept. The only reason why the bending here, and you will see in such question here, the direct stress here will be the sum of this one and this one, because the bending force somehow also create what we call a direct stress. So this is what you need to know under this part here. Now, Mr. Kotso, to do answer you, my brother, I just wanna know, I just wanna understand why you are saying that for R we should simply use 50. Maybe you do have a reason for that, and it's important to know. Did I answer you, Mabuza?
Yes, thank you.
You're welcome. Mr. Koso, please speak, my brother. It's important to clear our doubt before we move to class. So if you don't feel comfortable about something, we can speak out about it and we discuss. Please, my brother, why are you saying that we should use fifth chair?
No, it's fine, Mr. S, no problem.
See, my brother, now you are behaving like a politician.
No, I can see you're correct.
Okay, okay, my brother. Kosi for life, my brother. Kosi for life. Mr. Koso, you know, since 2022, we agreed that you and I will go on the stadium and watch soccer together. Pi over 64 d 0,08 0,05. So what's the answer? Is a positive bending. What's the answer, Mr. Koso?
Yeah, Mr. Ice, my brother.
Yes, my leader.
You see, when now you're talking about, you see now you are talking about the positive bending there, right? But at the same time, you see that bending is from the direct force, and that direct force is negative. So while saying that the bending is positive, is it because like they didn't say that the bending moment is
No,
negative or
the
what?
bending here
Or just
will be. Okay, let me answer you. What I'm saying, the bending is positive. When you read the problem, they say compressive, right? Do you agree that this force is negative because of this information? I want to answer you. I will
I
ask.
do, yeah, I do understand that when we have a compressive force negative,
Okay, wait. Can you please quickly ask your question
a
so that
negative force.
when we have a compressive force, is negative here. Compressive means going towards the object. That's why it's negative.
Yeah.
Now, when I'm
Now I
talking,
want to understand why yeah,
you
the
want to
bending moment is positive.
no, the bending moment will be negative as well. When I'm talking about bending positive, look what's happening, Mr. Bubakar. If you have, that's why you have to be able to see it practically. If this is the shaft, remember, what is the value of this force here? It is 1.7 kilonewton. Do you see it, right?
Yeah, I can see it.
So do you agree it's a positive value?
Yeah, I agree that it's positive there, Mr.
Well,
Az.
let me
But
finish, my
isn't
brother.
they will never write the negative, they will never write the negative value there. Like the sign matter will depend on the
My
what would
brother,
I say?
this simply means this force that is creating the bending is applicable upward. It's bending the object moving upward.
But Mr. Ice, when you're solving this part here, you say that that bending is due to the direct force. That's what you said. Are we gonna have like two bending, the one for the direct force and the one for the bending moment?
Mr. Waka, you shouldn't hear what I've said.
So we won't have two bending threads.
Let me repeat myself. I
Hey,
said
so we won't have two compressive threads. Sorry, the one
Mr.
for the
Koso,
direct force,
we're
one
gonna
for
have we're
direct
gonna have
force,
two
one
compressive
for
force.
bending moment.
Look, I said the bending moment here. This force is creating a bending, it is also creating a direct stress. When I'm saying that this force is positive, Do you agree that the force here is bending the object going up? This is the effect felt in this case. This is it. If it is moving this object up, let's say we are like this, you will have a tensile down here,
Yeah,
and you will have a
the
compressive
compressive up
on top.
there. Yeah.
That's one of the reasons why the bending moment felt here will be a negative. Eh?
Oh, nah. Huh? No,
Yeah,
I understand. No, I do understand. No, your point. Yeah, it's fine. I understand, Mr. Az.
yes, my brother. Yeah, I'm receiving call. Yes, position. 1 minute. Hello? No, I'm really busy now, so I'll go. Hmm. I'm coming, guys. No. Yeah, man. Hey, Mr. Walker, time flies, eh? Sorry, guys. Sorry, I was on the call quickly. But it's important we understand this. Now, here's what's happening, guys. If the force is pulling up, on this side it will be tensile, on this side is compressive. If the force is pulling down, on this side is gonna be tensile, on this side is going to be compressive. So for the guy that we will have here, we're going to have one answer, but with two different signs. What do I mean by that? What's the answer here if you calculate? That's one of the reasons on your textbook when they are solving this. They said it is compressive at the top or compressive at the bottom. Just the theory about it. Since 2,5 is pulling this up, it means on the top here, it is going to be a compressive, a negative. At the bottom is going to be tensile. This is what's happening here. So the answer that we'll have here, we're going to have two answers. We're going to have two answers. The one that is negative and the one that is positive. But do not, okay, here's the trick about this thing. I think I should state this here. The most critical is the addition of these two direct stress. But this is what's happening. Let's say this force was tensile. It means it's going to be a positive answer, right? Because the sum of the, can you please give me the answer first, please, guys? Please. The answer here, I will write plus minus. Plus minus, what's the value, guys? I will explain the reason why it is plus minus. The simple reason is at different position, the same compressive stress is being positive, and at another position it is being negative. Hello, Mr. Koso, are you with me? What's the answer so that we can move, guys? Hey, Mr. Kevin, my brother.
Mr. Ice, I'm feeling 39.91 MPa.
39.91 MPa, megapascal.
39.91 MPa. Now,
Yes.
guys, remember, these two direct stress they add. But here's the thing. The most critical addition that we want the
But guys,
maximum.
me, I'm getting 59 something. I don't know if
Mr.
I did something
Bubaka,
wrong.
if you are getting
Huh?
69, I don't know who's making a mistake, but that's
Sorry, man.
I
Maybe
wanted to
it's me.
say that's none of my business, but I wanted to say meanwhile I'm responsible for this. Mr. Bubaka, why are you having a 59, can you please check your calculator how you are putting it? Okay, guys, the M in this thing, okay, let's say it is 59 or 39. At this point, it doesn't matter. But what I want to show you is when we want to have the sum of both direct stress, here's the thing. We want the critical one. It is the sum. By critical, we mean the maximum, like the biggest value. I know if I had, how can I explain this in the simplest word? Remember, this guy is plus minus. When I'm doing the addition of this stress, I would add minus 16, 32 minus 39,91 to give me the direct stress summation of it. We call it for most critical axial stress, we do the sum of the two stress. What does that mean, Mr. Kotso? It means if this guy was a tensile, it was positive. It means in this case, the direct stress would be the positive answer plus the positive answer of this one. That's what I'm trying to tell you basically. So when you will be doing the sum of this direct stress, you add the guy with the same sign, or you add with the sign of the direct stress for you to get the critical direct stress that you need. I don't know if my English is making sense. Remember, this one is plus minus because at certain position it is positive and is negative. But which one do we need? We will need the one that will match with our direct stress. So if the direct stress is negative, like in this case, we will have negative minus negative. If the direct stress is positive, which is tensile, we'll have positive plus positive. So at the end of the day, the direct stress that we have is 16 minus 39. It should give us the full answer. Mabuza.
Yes, Ice, you can continue.
Okay, yes, this is the direct stress. Next, guys, remember when we have the torque creates what we call a shear stress. It does create it. So how do we do it? Torque, we call it shear stress, rho xy. I don't know if you remember, because rho xy, it is rotating around x and y. Remember, if you have, let's say, a cup. Why am I saying a cup? If you have a bottle, when you open your bottle, that is a torque. I mean, that's a shearing stress. Like, Mabuza, if right now Mr. Kotso hold your hands and turn your hands around with so much violence, it's going to break your arms. It's going to shear it. That's what shear stress means. So the shear stress it is torque times R over J. Now, torque is given as what, Mr. Abubakar? Is given as 2.2. So it's given as 2.2 times 10 to 3. R, remember, R is the same thing as Y. We take the biggest one, which is 0.04. Now, J is pi over 32. This is moment of inertia. J is the polar moment of inertia. We've done it in strength of material too, but that is a couple of years ago, eh? So, but I do understand. Pi over 32 is still the same thing, d4 minus d4. So it is d0084 minus 0054. You have what you have, the polar moment of inertia. So once you have everything here completed, you'll be able now to get what we call the principal stresses and then solve for Tresca and Van Moss theory. But before, these are the steps. I'm going to send a new link so that we can finish this because we are left with how many minutes? Yeah, it will end soon, less than 2 minutes. But meanwhile, we can speak for 2 minutes before I send the link. So far, are we on the same page? Mr. Kevin, are you with me, my brother?
Yes,
Okay, my leader.
I'm with you.
Mr. Ice, please share the screen. I didn't copy everything.
Oh, you want to? Okay, my leader. Let me do this. Yes, guys, and for exam, that's the biggest discount that I can do because I felt like at some point I've let you down. So it's 350 for all the subjects. Hey, my brother, that is
Where did you
55.
get that?
Where did I get?
The talk value? Was it on the question?
Yes,
Okay, is it 2.2, right? It's 2.2.
2.2.
Okay, sure.
2.2 times to the 3. Hey, Mr. Bubakar, my brother, let's talk. I know with you, I've said things that we're gonna talk. If this video closes, it
Mr.
means
Mr.
it
Ak-
ended and I'll send a new link. I know with you, I have said things
Oh,
that we're gonna talk, my brother.
yeah, man. There is always something to say, man, and to talk about.
Yeah, my brother. We graduated together, Mr. Bubakar.
No, bro, we didn't.
We graduated on the same day.
Yeah. Same day, same day. I remember. Yeah, Mr. Ice, my brother. So, man, when we see vibration, bro, we need to do. You remember that part there? Last time you said now we're going to do this part, but we didn't do it.
Yeah, we have to, my brother.
Yeah, we have to, man. Whether it's like those and gears, actually.
Yeah.
Yeah, we need to cover that part. Ish,
Mm.
oh, man.
How is Xavier? I haven't
And
seen him for a while.
I mean, he has been saying that the exam won't be easy, won't be easy. I don't know why.
No, Xavier is just like to traumatize people. Xavier is a cool guy, my brother.
Ish, man.
You
It's
want
just
him
like,
to
no, push, study. The exam won't be easy.
Mr. Kevin. Laughing.
I fine.
Okay. Yes, guys, I want to send a new link and we finish this question. But meanwhile, yeah, you can speak. If we all on the same line, we can move so that we can, yeah. Can I close and send a new link?
Yes, we can, man.
It's true.
Sure. Offside. I think we are all here. Who's missing? There's Khotso Abubakar. Let's give him 1 minute. Bellingham. Bellingham. Hey, I don't know where is Abubakar, but we can move. Zandile Mabuza. So this link would be on my YouTube channel. So your name shows on my YouTube channel, Mr. Khotso Jamza. So guys, if you have the money, you can make the payment, and yeah, you know.
Mr. Rice, I can see that you and Mr. Khotso, there's something special between you two, huh?
How?
Mr. Khotso. Mama line,
Mr. Ice is my man. We
Yeah.
come way back.
I know.
So me, I've been doing my first online classes. It was with Mr. Khotso. There was Khotso, Tembi. I mostly remember Khotso, Tembi. They are the guys who pushed me to start online classes.
Don't forget Ntombi. We're with Ntombi.
That's what I'm saying. Khotso, Tembi.
She's married now. She's
That
married.
name,
She has a kid.
Hey, she had a kid. She's still with the same guy, my brother.
my guy, Mr. Ice, that name in Swahili means a lot, bro.
What does it mean?
It's heavy. Ask Mr. Kevin.
Mr. Kevin, what does Tombi mean?
Tombi, Abubakar, it doesn't mean Tombi. Oh, you're talking about Muntombe. Tombe, yes, it means something, but not Tombi. Tombi, Abubakar, I don't know, man.
What does Mutombe mean?
That one is, I can't say it.
Okay, that's not the thing. Let me ask Mr. Koso. You said is Tombi is married now?
Yeah, she's married.
With that same guy, my brother.
Yeah, that same guy.
Hey, my guy, that guy. Congratulations. They've been since 2022.
My guy, that guy, what is wrong? What is wrong with that guy?
No, there's nothing wrong. I'm just saying it because they've been for long, and I'm just asking the same guy because it's really difficult.
Oh, did you visit the house before the guy?
No, Mr. Abubakar, I told you that I don't tackle my students. I don't do that. No matter how beautiful you are, I don't do that.
This man, go to heaven, huh?
No, it's principle. I don't do such thing. If
My
you get
guy.
one student tell that I did what, it's a lie. Yes. What do we do, Mr. Abubakar? Yeah. Okay. My first online classes was Mr. Khotso. Can you please give me the answer, Mr. Khotso, Tombi? Yeah, they're the guy who pushed me to do online classes.
Mr. Ice is 25.82 MPa.
When was it? Last year?
2022.
Way back.
Oh,
2020. 2022, no, Mr. Ice.
Yes.
Finally.
2022 finally. But I think I knew Mr. Kotso. Was it first semester when I said I was doing fair of machine? I think
Yeah, it was first semester.
yeah, first semester in the house. That's when I started my classes actually. My debut was not easy, Mr. Abubakar. When I started classes, the guy that was giving classes was given Aaron and everything. So when I started these classes, I was like, how am I gonna get people and what? And I just started. I went to see Xavier. I didn't even know Xavier, to be honest. I didn't even know him personally. I went to him, I've spoken to him, and he gave me a chance. That's where all it started. And after I did that, everybody followed my move. And I changed. I did online class. Now everybody is doing online class. So somehow, I'm goated.
Don't forget to mention Mr. Ice. I gave you the idea for online.
Yeah, my brother. I won't forget you, my brother. When this YouTube channel boost, yeah, it will boost definitely. I won't forget you. Okay, guys, let's move. We have Tresca and okay. Next, we have to solve for the principal stress. After this, how do we solve for the principal stress? If you remember this formula that says that rho 1 to what we call maximum. Let me just try to rewrite it so that we remember what it is. Let me check again from my textbook. Yes, Mr. Bubakar, that's my story about Mr. Kotso. That's the reason why you see we are close like this. They are the people that has pushed me in this thing.
so meaning you are not a therefore. Just kidding.
What's the therefore, my brother?
Huh?
No, my brother, we don't do those. This video will be on YouTube. I don't want to say gay things, but we don't do that. We don't do that. But you went far, my brother. You went to think like that. Now I'm worried.
No, man, I was just kidding.
No, I'm worried. I'm worried, my brother. Are you playing on the other team, my brother? If you think like that, no. If you are playing for the other team, my brother, it's okay.
Mr. Ice, time management. Let's continue.
Yeah, I'm just copying the formula so that we can do. Mr. Bubakar. So now, Mr. Bubakar, you are also boosting me right now on this year, so I won't forget you.
Thanks, my brother.
Okay, guys, this is what we call by principal stress. The rho y stress, it is 0 because we are focusing on the direct stress on X that is coming to this element here. So if you have to apply this formula, direct stress rho 1, direct stress rho 1, 2 is going to be half. What is rho X? Rho X is the sum of those guys there. What's the sum there, my guys? Mr. Bubakar, did you still get 59 or it was 39?
No, it's 39, sorry.
Yeah, if
39.
you add those two, minus 16 and 39, what's the answer? That's supposed to be rho X. What's the answer?
Ice.
Yes, Mr. Kevin.
Mr. Ice.
Yes, my brother.
I didn't understand. I didn't understand the rho y is equal to 0 minus rho 1, 2. I don't know if you
No,
can
it's
repeat
not
that.
minus. It's my. It's not.
Yeah, I was kind
I'm
of a bit
laughing. I'm
scared.
sorry. Rho y
Okay.
is 0. So therefore, rho 1, 2 is half. The reason why rho y is 0 because we do not have stress on the y. We only have a direct stress on the x, which is the sum of these two. That's the reason. So it was not like rho y minus rho 1 to no. So the answer, it is minus, what is minus 16 minus 39? What's the answer? 40. This one is giving 40. 55. It's giving 55. It's giving 56.
So you said minus 16.
Minus 16, 32, minus 39, 39. Those two stress, when you add them minus, they're supposed to give minus 56,
minus 56,23.
Around there. Plus minus rho half. Remember, this one here is 0. So you basically have minus 56,23. This is what's happening. Plus 4 rho xy square, it is 25,82 square. But now you have to remember, you have rho x minus 1. So when you do this question, you'll have rho 1, you'll have 1/4, that will be positive, that will be tensile, and you'll have another stress that is compressive. What's the answer? Okay, we'll call it rho 3. I will explain why we said rho 1 and rho 3, because when we use the Tresca and Van Mosses, the direct stress 2 is 0. So normally, let me just change it here to avoid confusion. Let's call it rho 1 and 3. What's the answer of rho 1? What's the answer of rho 2? You have two answers because you have plus minus. You will do this calculation with plus, you get an answer. You will do this calculation with minus as well. And Mr. Koso, last year before I left the Valve, I had a manager.
Besides, for that one, I'm getting 10.06. If they can confirm for rho 1. Hello?
For you are getting 10,
06.
For the second one?
I'm getting minus 66.29.
Yeah. Okay, guys, now we have to use the Van and Tresca. Here we go. How do we do it? There is also a formula for Vans and Tresca. What is it again? I'm just recalling it for you. The formula for Von says that rho 1 minus rho 3 is equal to SYT. SYT is the yield strength over N. Now, what is the question asking us to get? Normally, in these cases here, if you have the yield strength, they will normally ask you for either N. N is what they call the factor of safety. Or you are given N, you are asked to get the yield strength. That's all they're gonna play around there. That's where they're gonna play. So by using the Von method, this is the formula. So what you do is you simply play with this guy here. Now, what is rho 1? Rho 1 is 10,06 minus of the formula.
Nice. You said they will either give us the factor of safety or the what?
It's either you will solve for the yield strength or for the factor of safety. If you are given the
Okay.
yield strength, in this case is given to us, I think it's 200, 320. Therefore, we solve for n. Or in other case, you can be given n and you solve for yield strength. That's what I'm saying. These are the two possibilities, Mr. Kevin. Is it fine, my brother?
Yes, sir.
Yeah. Now we have minus of the formula again, minus 66,29 to be equal to SYT, which is 320, and then you have N here. So don't worry about the conversion here, because here you have megapascal, and these two will add as megapascal, they will cancel out. So what is N? You can get N, guys. Remember, if you add these two, you will get a positive answer. You will get something like 76,3 if you add these two. Minus minus gives 3. So what you're gonna do, what is N? N would be 320 divided, what is the answer here?
Pokemon 19. Ice.
It is what?
4,19. 4,19.
Oh, this is the final answer, eh?
Yes, I don't know if other people got another
Yeah, it's
answer.
fine, my brother. For Tresca, there's also a formula for Tresca. What's the formula of Tresca? So this formula of Tresca says you have rho 1, rho 2 square plus rho 2 minus rho 3 square plus rho 3 minus rho 1 square to be equal to 2. You need to remember the formula here. SYT n everything square. So yeah, we substitute again. That's how easy it is. Rho 1 is what? It is this guy. Remember, rho 2 is 0. So you're going to have 10,06 square plus rho 2 is also 0. But remember, this one is minus. Again, minus of rho 3 which gives plus. So you have 66,29 square plus rho 3 here is minus 66,29 minus rho 1 10,06 square to be equal to 2. Remember, if you put everything square, SYT square will be 320 square over n square. So if you can do that, you can solve for this problem. Yet you can add this one here. Let's do this. Let me say that all the answer here is alpha. So you'll have n to be equal to 320 square divided by alpha. Everything inside the root, because this one is n square. Remember, alpha is the answer that you add here. So if you do that, you have the factor of safety. So what's the answer?
Everyone, I'm here in George on the Wyong solar plant that we're building with Solar Energy Africa. With me, I've got Clayton from Lumax and Ludwig, who's also from Solar Energy Africa. He's quickly going to explain to us what we're doing on the site. So, as you can see there between.
Wait, 1 minute. Arrive. Oui, allô? Non, ça va, là. Et puis, bon, en ce moment, j'ai aussi tout en place pour l'histoire de conclusion. J'aimerais envoyer le côté chien pour Adrien Manuel et demain. So yeah, that's it, guys. I will give you. I need to attend to a call now, guys, but that's basically it. So at this rate, you're not moving fast. I will try to write down some question and send to you so that we will save time that way. Sure. Let me stop this recording.